Boeing can build almost anything: advanced wings, composite fuselages, and complex flight systems. But there is one component Boeing refuses to build, even though it represents enormous profit potential. The reason traces back to a decision made nearly a century ago. Here is why Boeing refuses to make its own engines. For most people, commercial aviation is the story of Boeing. The name is printed on fuselages. It appears when booking flights. It dominates aviation headlines. Yet the most complex, most expensive, and most strategically critical component on every aircraft Boeing builds is something Boeing does not make: the engines. This makes no sense on the surface. Boeing designs wings capable of flexing 7 meters under load. The company engineers fuselages from carbon fiber composites that withstand pressurization cycles for decades. Boeing integrates millions of lines of software into fly-by-wire flight systems. This is one of the most technically sophisticated manufacturing organizations on Earth. Yet Boeing does not build the component that actually makes its aircraft fly. The financial stakes make this even more puzzling. Engines are where the real money sits in aviation. GE Aerospace alone generated nearly $45.9 billion in revenue in 2025. Pratt Whitney earned $32.9 billion. Rolls-Royce Aerospace brought in $13.7 billion. These three companies form an oligopoly that has not faced a serious new entrant in years. So why does Boeing not simply build its own engines and capture that value? The answer traces back nearly a century to a decision that reshaped aviation permanently. In 1929, William Boeing and Frederick Rentschler, president of Pratt & Whitney, joined forces to create the United Aircraft and Transport Corporation. It was aviation's first vertically integrated empire. Boeing built the airframes. Pratt & Whitney built the engines. Propeller and airline divisions rounded out a machine that controlled nearly half of American aviation. United Airlines flew the routes. Everything was in-house. One corporation controlled the entire chain, from raw metal to passenger. By any modern definition, it was a monopoly. By 1934, Congress had seen enough. The airmail scandal exposed how cozy relationships between manufacturers and airlines had corrupted government contract awards. Lawmakers moved swiftly to prevent it from happening again. The Airmail Act banned airframe manufacturers, engine makers, and airlines from existing under the same corporate umbrella. United Aircraft and Transport Corporation was forcibly broken into 3 separate companies. United Airlines became an independent carrier. Pratt & Whitney was grouped into United Aircraft Corporation on the East Coast. Boeing was left alone on the West Coast, stripped of its engine division, stripped of its airline, stripped of its propeller company. William Boeing, reportedly furious, sold his stock and left the industry entirely. That 1934 breakup established the structural separation between airframe and engine manufacturing that persists to this day. It was not a market outcome, it was a political one. And its consequences have defined aviation for 9 decades. But Boeing did try to return to the engine business. Starting in the mid-1940s, Boeing launched its own gas turbine research program. By the late 1940s, the company had developed the Model 502 turboshaft engine. Through the 1950s and 1960s, Boeing manufactured a range of small gas turbine engines. The division produced more than 2,000 engines total, powering everything down to boats. This was real engineering, real production, real hardware, but it was loss-making. Boeing faced a choice: continue pouring resources into a small engine business that could not compete with the scale and specialization of GE and Pratt & Whitney, or redirect that capital toward the most ambitious airframe program in history. That airframe was the Boeing 747. By April 1968, Boeing produced its last engine and closed its turbine division permanently. Every dollar and every engineer was reoriented toward building the jumbo jet. The decision proved transformational for commercial aviation, but it also represented Boeing's final admission that engine manufacturing required a fundamentally different kind of company. Boeing briefly re-entered propulsion through its 1996 acquisition of Rocketdyne, a storied rocket engine manufacturer. But even that venture proved unsustainable. Boeing sold Rocketdyne to Pratt & Whitney in 2005. A quiet but telling admission that engine making of any kind was simply not Boeing's business anymore. This is not about lack of ambition. The reason Boeing could not make engines work in the 1960s is the same reason Boeing does not attempt it today. The economics are genuinely prohibitive. Developing a modern commercial jet engine now costs perhaps $10 billion, possibly more. GE Aerospace spent $1.5 billion on research and development in 2025 alone. The CFM LEAP engine, which entered service in 2016, did not break even until 2025. That represents 9 years of negative returns before generating a single dollar of profit. And that is for a company that already possesses the expertise, testing infrastructure, supplier relationships, and certification experience. For a new entrant, the timeline would be longer, costs higher, and probability of failure significantly greater. Consider China's AECC, developing the CJ1000A engine to replace the CFM LEAP on the COMAC C919. Originally targeted for 2020, certification has slipped to 2027 and could slip further. Mass production is not expected until 2030. A decade of delay with practically unlimited state funding and explicit national priority behind the program. Even that cannot shortcut the physics. The technical barriers are staggering. A modern turbofan operates with internal temperatures exceeding the melting point of the metals from which it is built. High-pressure turbine blades survive only because of single crystal metallurgy and thermal barrier coatings developed over decades of classified military research. Tolerances are measured in thousandths of a millimeter. A single flaw in powdered metal manufacturing, as Pratt Whitney discovered with its GTF engine recall, can ground hundreds of aircraft worldwide. This is the business Boeing would be entering, one where $10 billion buys you a chance, not a guarantee. But the financial barrier extends beyond development cost. Engine makers operate on a fundamentally different business model. They do not primarily make money selling engines. They often sell engines at a loss. CFM International routinely discounts power plants aggressively to place them on aircraft wings. The real revenue comes afterward. Over a 25 to 40-year engine lifespan, manufacturers earn through maintenance, repair, and overhaul contracts. Rolls-Royce pioneered this in 1962 with its Power-by-the-Hour program, where airlines pay a fixed cost per flying hour covering maintenance rather than paying for each repair separately. GE Aerospace reported that services accounted for around 30% of its total commercial engine revenue in 2025. Boeing operates on completely different financial rhythms. It builds aircraft, delivers them, collects payment, and moves to the next order. To enter the engine business, Boeing would not just need to build engines. It would need to build an entirely separate company with different financial assumptions, different time horizons, and different risk tolerances. The payback period stretches across decades rather than delivery cycles. But here is where the story takes its most important turn. The reason Boeing does not make engines is not just about cost or complexity. It is about what building engines would destroy. Today, Boeing offers the Boeing 737 MAX family with CFM LEAP engines. Airlines value the relationship between airframe makers and independent engine suppliers. If Boeing built its own engine, it would immediately become a competitor to GE Aerospace, Rolls-Royce, and Pratt Whitney. These are the same companies that power every Boeing aircraft in production. GE holds a monopoly on the 777X through the GE9X, the largest engine ever built. CFM International, GE's joint venture with Safran, provides the only engine option for the Boeing 737 MAX. Boeing building an in-house engine would not just require $10 billion in development. It would destabilize every existing supply relationship. Airlines would question whether a Boeing engine had been designed to optimize Boeing's profits or their operational performance. Competitors could offer airlines independence from a vertically integrated monopoly. The competitive advantage Boeing might gain from capturing engine revenue would be more than offset by the strategic damage to its airframe sales. Emerging technology reinforces this arrangement rather than disrupting it. GE Aerospace is spending billions on next-generation research, including its OpenFan CFM RISE program. Rolls-Royce is pursuing UltraFan, a demonstrator that ran at full power in 2023, These programs promise 20 to 25% fuel efficiency improvements, but every one requires decades of specialized research that only dedicated engine manufacturers possess. Each demands testing and certification infrastructure Boeing has never built. And each will be offered to both Boeing and Airbus because that is the only way to generate sufficient volume to recover the investment. The aviation industry has always assumed the company whose name appears on the plane matters most. Boeing builds the Boeing 787, but engines now represent a large chunk of a modern aircraft's value. In a meaningful sense, Boeing is an aircraft assembler. The company integrates systems designed and manufactured by others, coordinates global supply chains, and ensures certification of the finished product. But the heart of every aircraft Boeing delivers, the component determining fuel burn, noise, reliability, and ultimate airline profitability, belongs to someone else. This is not a weakness Boeing can fix. It is a structural reality born from a 1934 antitrust decision validated by Boeing's own failed engine division in the 1960s and hardened into permanence by the billions in development costs and decades-long payback periods that define modern engine programs. The question is not whether Boeing could theoretically build an engine. Given enough time and capital, perhaps it could. The question is whether anyone at Boeing is willing to bet the entire company on finding out. So far, the answer has been no, and it likely always will be.